All right, good morning, fourth grade. So today's lesson, this is day 4. So I'm pretty excited about that because I'm actually starting to catch up a little bit. Slowly but surely, gotten faster at getting these things out. And today is really cool. It's about benchmark. So this word benchmark. And a benchmark just means something that you use to compare. And for example, benchmark is just something used to compare. Okay, like in fractions, the benchmarks are things like 1/2 and 1. It's like, you go to the refrigerator, you got some friends coming over, and you pull out a big sheet of pizza. You look at it, and you're like, whoa, that's like less than a half. I don't even want to, warm that up because we're not going to have enough, and my friends are going to be cranky about that. You just, in your mind, you know what a half is, and so you just look at it. You don't need to know exactly. Just like, that's less. Or you pull it out on a different day, and you're like, whoa, I got more than 1/2. I got more than 1/2, Maybe you look at it and you're like, well, it's almost one. Almost a full pizza. That's an example of using benchmark. It's something that you have in your head. You know what that looks like, 1/2 and 1 whole. And so then you can kind of compare things and make some decisions, like whether you're going to eat that pizza, save it for yourself for later, things like that. Important decisions in life. So that's what we're doing. We're going to use a benchmark to compare, just like a little example I gave you. So here you have Carol compared 3/4 and 2/1, which is kind of weird, the way they have that. She says 3/4 is greater than 2/1 because both the numerator and the denominator in 3/4 are greater. So she's trying to apply some math reasoning. She says, oh, okay, here I got this 3/4 and I got this 2/1. And she says, hey, both of these guys are bigger. This numerator is bigger and the denominator is bigger. So therefore the fraction is bigger. And so she's trying to use some math reasoning. However, what do the denominator and the numerator mean? So in this case, this denominator means that it takes one piece to make the whole. So in other words, if we're talking pizza, one piece is a whole. In other words, we're talking about this. One piece is the whole. So let's do it. Here's one piece. There you go. Now, how many of these one pieces do we have? How many of these do we have? It says we have 2. So in other words, what's going on here? We have 2 of these big pieces. And this is where you just want to, what does the numerator and denominator mean? It all comes back to that. I have 2 of these big pieces. And it only takes 1 to make a whole. That means I have 2 wholes. That's what it is. That's all that is right there. 2/1 means 2 wholes. So in this case, what's the girl's name? Carol. If she would have thought a little bit more about, what a numerator and denominator means, she'd have been in better shape. So here's what the deal is. 3/4 is definitely less than. Okay? And then they want you to compare it on to a benchmark of 1. Compare it to a benchmark of 1. So easily you can say, okay, well, 3/4, here's 1. That's less than 1. So 3/4 is less than 1. Okay, so 3/4, that is less than 1. 2/1 out here, that's greater than 1. Okay, that's another way of saying that. 2/1 is greater than. So here's the reasoning. If 3/4 down here is less than 1 and 2/1 is greater, well then that means, hey, 3/4 is less than 2/1. And then this is just turned around the other way. No big deal, right? All you're saying here is that 2/1 is greater than 3/4. It means the same thing. Main thing is, we're talking about a benchmark. Common benchmarks you're going to be looking at today are things like 1/2 and 1. You got this. Watch this. Okay, so let's come down and look at number 1. Okay, number 1 here. It says we're going to compare 9/10. So we got 9/10. And 3/3. Okay, wants us to label 9/10 and 3/2 on the number line. But first, just observe these two fractions. Okay, what does that denominator mean here? 9/10, the denominator means 10 parts to make a whole. You have 9. You've got almost 1 whole. Okay, but 9/10, it's less than 1. So we could, you could come over here and say, well, it's less than 1. Okay, watch how easy. Over here, this other pizza, this one says you've got 2 parts that makes a whole. 2 parts makes a whole. So, you know, like a pizza cut in half. 2 huge slices makes a whole. You have 3. All right? You have 3. You've got, like, here's 1, and then you got this other. You've got 3 of these things. 3 parts. And it takes 2 of them to make a whole. So you have 3 halves. You have 1 and 1/2. That's what that's equal to. So that is greater than 1. Okay? So now you got it. So look, we can do it on the number line. That's fine. Let's take a quick look on the number line because that's important. So basically you have a 0 and 1, and you have this thing split up into, the whole is split into 10 parts. 1, 2, 3, 4, 5, that's 1/2. 6, 7, 8, 9, 10. And you have 9/10. So you can also place it on the number line. There's 9/10. 3 halves. Okay, 3 halves would be a little bit harder, but what you could do is say, well, I know that, remember we talked about this, 1, 2, 3, 4, 5/10. That's 1/2. So I have 3 of those. So you could say, okay, I got 1, here, let's use a different color. I've got 1/2, 2 halves, 3 halves. You could do it that way. You could just say, wow, there's 3 halves, which is the same as 1 and 1/2. You could also change 3 over 2. You could say, well, let me just change that to a, let's rewrite that as a fraction where 10 is the denominator, so that we have, you know, the same denominators we talked about. That's a good way to compare, right? So I am going to have to multiply that times 5 and that times 5. And that's 15/10. And that's another way of showing it and saying, oh, there, my 3 halves is the same as, whoops, my 3 halves is the same as 15/10. Okay? Which fraction is greater than 1? Well, we looked up there and did that, 3 halves. Which fraction is less than 1? We said 9/10. Fill in the blank. Explain how you found your answer. 9/10 is less than 3 halves. Well, you have 3 ways. 1, we compared them up here. This is like sort of number 1. We compared them to a benchmark fraction of 1. Okay, and that's basically what they're asking you to do here. You can say, you know, I compared each fraction to the benchmark, which is just a fancy name. Benchmark means the one you know, benchmark of 1. And you can just say 9/10 is less than 1, and 3 halves is, oh, we could write it out, or we could just even save time. Let's just use our math symbols. Math code is greater than 1. And a lot of times in a math statement, you can use this big fancy word that just means so, but a better word is therefore. I know. And all this is logical thinking. So that's the nice thing about math. You're learning how to think through something logically, and you just use it everywhere. You use it for problem solving. Later on, if you want to do like anything on computers, or you're working with, you know, groups of people or a company or planning a party, whatever you're doing. It's a lot logical thinking. Therefore, I know 9/10, because 9/10 is less than 1 and 3 halves is greater than 1. I know 9/10 is less than 3 halves. Ta-da! That's it. You got it. All right, let's do the same thing here. We're going to compare 5/6 and 1/3 using the benchmark 1/2. Okay, 5/6 and 1/3. So looking at 5/6, if you have a pizza with 6 parts, I have trouble getting right in the middle of the screen. If you have a pizza with 6 parts, what would be 1/2? Well, 1/2 would be 3 out of 6, wouldn't it? Think about it. That would be 1/2. So automatically, you know 5/6 is greater than 1/2. Okay? You automatically know that. All right, let's look at the next one here. So 1/3 is a pizza cut into 3 parts, and you only have one of the parts. Okay, so it would look like this, right? Pizza, 3 parts, and you just have one. So that should tell you right there. That's cut into more. I mean, 1/2 would be, you got 2 big pieces. So these have to be smaller. So this has to be less than 1/2. And there you go. You just used a benchmark fraction to make a comparison. Okay, so you actually know. Which fraction is greater than 1/2? 5/6. Which is less than 1/2? 1/3. So that means 5/6 must be greater than 1/3. And the other thing you know about 5/6, it's got to be more than 1/2, because how many parts does it take just to make one whole? One more slice, and you have a whole pizza. So it's really close to one whole. Okay, so the other thing you can do is we can do common denominators. So let's see, what do we have here? So we can do a common denominator. And again, I think the easiest way to do that is you do your skip counting. Okay, so you skip count by 3, and you have 3, 6, 9. Skip count by 6, 6. You don't even have to go any further. Look, I can. What this is telling you is I can create 2 pizzas that have 6 slices, or I can take the whole and I can put it into 6 parts. So let's do that. Let's put this whole into 6 parts. Now, one of them is already in 6 parts, and that is 5/6. So let's put 1/3 into 6 parts. So I have to go times 2 times 2. That's 2/6. So let's put these on the number line. Well, how many parts to make a whole here? I've got 1, 2, 3, 4, 5, 6. So I already have 5/6. And then I just said 2/6. So I can put that on the number line. And that I can also compare. So if 1/3 is the same as 2/6, remember 1/3, this is the same as, I can still say 1/3 is less than 5/6. Now you might say on here, well, how come they have 1/2? Why don't they have 3/6? Well, because what you're going to learn later is fractions are usually simplified. So basically you take a fraction like 3/6, and then you can write it in its simplest form. In other words, think of coming home from a party, and there was a small birthday cake, and it was just a couple people, and if you said to your mom, I had 3/6 of the cake, what's a simpler way to say that? It would be 1/2. Mathematically, it just means you just find a number that you can divide both the numerator and the denominator by. And as long as you can divide this, that means you're simplifying that fraction. See, it's much simpler. It's just 1/2. That's all you're doing there. Okay, let me get rid of that. Then you got your explanation here. Explain how you found your answer. So I would say I compared 5/6 to 1/2 and 1/3 to 1/2. I found that 5/6 is greater than 1/2 and 1/3 is less than 1/2. Let's use the big word. Therefore, instead of saying so, it's therefore 5/6 is greater than 1/3. Ta-da! That's it. Okay, let's keep going here. Use a benchmark fraction to compare the fractions 7/10 and 5/12. Explain how you found your answer. So you could do a couple things here. I would say let's just do 1/2. Let's do 1/2. So how does 7/10 compare? How does that compare to 1/2? Okay, this is where your knowledge of the denominator is really important. That denominator has 10 pieces. In other words, that pizza would have 10 slices. If you want half, you got to have at least 5. You have 7, right? you have more than 1/2. Okay, you got more than 1/2. Let's look at 5/12 and 1/2. Okay, this time our denominator is 12. That means that pizza is cut into 12 parts. If you want half of that pizza, you got to have 6 slices. You only have 5. So you don't even have a half. You have less than 1/2. Okay? You have less. So, same thing. I compared both. Sorry for the handwriting. Again, I have to write kind of vertically, and it's really hard. I compared both fractions to the benchmark 1/2. 7/10 is greater than 1/2, and 1/3 is less than, no, 5/12. So I'm thinking about the other one. Whoops. 5/12 is less than 1/2. Big word. Therefore, makes you sound really intelligent, which you are. Therefore, 7/10 is greater than 5/12. Remember, 7/10 is more than a half. 5/12 is less. That means 7/10 has to be more. Has to be more. It's also only 3 slices away from a whole pizza. Okay, and so that's helpful. And this one is 7 slices away. So that can also help us a little bit as well. Okay, let's see if we can get this last one in before my next class here. We're rolling along. We're rolling here. Tell whether each number sentence is true or false. Okay, and then we're going to write the benchmark that we use. So we have 9/8 and 11/12. These are both pretty close to 1. So let's use the benchmark of 1. This first one here, this has 8 slices in my pizza to make a whole, and I have more than 8. I've got more than 1. So this fraction is greater than 1. 12 slices in my pizza. I don't quite have 1 whole pizza, but I'm just missing 1 little teeny piece. But it is less than 1. So if 9/8 is greater than 1, 11/12 is less, 9/8 is greater than 11/12. That one gets a true. That one gets a true. Okay, let's do 2/5 and 5/6. Okay, so 2/5 is pretty small. Let's use 1/2 this time. So if I had a pizza, this would be weird. If we had a pizza with 5 slices to make a whole, and I wanted to do exactly half, I would literally have to do 2.5. 2.5. I'd have to get like 2 1/2 slices out of 5. That would look really weird, okay? But we can just know that, okay, we don't quite have 2.5, so we're less than.